Hey there, students. I'm taking you through these 6 or 7 different items that I missed on my first chemistry exam. This was back in 2007. I'm going to run through them as quickly as possible and then give you some context and things, steps I took to do better on further exams. So here we go. Number 1, the professor gave us the distance from home plate is 90 feet, and what is your distance in meters? Now, they tried to sort of mess with us and give us a conversion factor that's in 3 dimensions versus distance, which is 1 dimension. So we do need to do something to the conversion factor they give us. The conversion factor is right here. I'm gonna use a space down here in number 12 because I don't think I'll need it. In the next problem. Okay. So if we cube root both sides, we will get our first, we'll whittle things down to the first power, and we will have our conversion factor in the first dimension. So we know the cube root of 1 is 1, and then we just need our calculator to figure out 0.02832 is, and I'm doing that right now. So 0.002832, it's a cube root. I get 0.3048 meters. And I looked it up. Yes, it is the correct conversion ratio. I would not have that available on the exam. And apparently I might have pulled this information over here from another problem. This was like a 50 plus problem test. So I very well could have had that from another problem and thought, oh, well, I can use that. But clearly, and I got frustrated here. Notice I tried to apply feet, and then, but notice these are both cube, right? That clearly I hit a dead end. I went ahead and just made my best guess, and that might have been from the work I did up here, but I really can't explain how I went from meters to yards. Yes, maybe 30 yards. Yeah, maybe I divided by 3. Who knows? Oh, yeah, 90 feet is 30 yards. I might have gone that route, but clearly I did something wrong. But if we do apply, so if I take 90 times, and this is feet, 1 foot has the 0.3048 meters, I do, in fact, get 90 times the 0.3048 gives me 27.433 dot dot dot. But of course, we're using 3 sig figs here, 3 sig figs here. That is appropriate. Now for question 12, we have a swing of a frictionless pendulum. What energy forms remain constant? So we need to understand, like in is it free fall? Yeah, free fall of objects, and then we have pendulums. We use the concept that initial energy is equal to final energy, and that means it's constant, right? The difference between those is 0. They remain the same. And what this breaks out to is kinetic energy plus potential energy. And then we have kinetic, sorry about my whiteboard there, don't know what it's doing. All right, kinetic energy final. And this is where we're going to pull that answer. So the sum of these two, kinetic energy plus potential energy, will remain constant. That's key right there. I'm going to go ahead and circle that, remain constant. Yes, option D would be the best answer. Now, granted, I did not take physics yet. I probably had no clue how to answer this. That was a tough one. But options A and B are just kinetic and potential energy only. C is both kinetic energy and potential energy. No, because it can change depending on their height and their speed. And then E, none of the above would not be correct. Yeah, so we have option D as the final answer for number 12. Now, I don't have the question number here, but I am given, we're just simply converting a standard number over to scientific notation. Now, notice I put a negative there. That might have been just a typo. I did put the right number. I just didn't make it positive. But I should have done 0.2. I should have backed it up. You know, we moved the decimal places forward to the left, which means I would make it a positive exponent. However, for some reason, I just whittled down the significant figures. I do not know why. Do not know why. I should have just left it as 5.20302, 10 to the fourth power meters. Final answer there. Question 28. This one, all we have to really do here is look at the ratio. Look at the ratio of mass A to mass B and compare it to the other ones. I don't know why I answered. I'm looking at my answer here. So I circled D on the test in pencil, and I just flipped the ratio. That was nonsense. I probably didn't know what to do here. But there should be some kind of factor using the law of multiple proportions. Yep, proportion. There's a proportionality or a factor that would give us a ratio over here from options A through E. All right. So I did circle B. I would have talked to my teacher about this, I believe. I would have seen the answer key, or it would have popped up on the Scantron. I don't remember if she gave us the answers on the Scantron, but I would have talked to the teacher about this and determined that yes, B is correct. And if we look at 30.4 over 69.6, it turns out like if we take this ratio in decimal is 876, and then take that other ratio on the right, we have 436. And I know if we take that original ratio and divide it by 2, we get 438. These are not exact. If you go through A, C, D, and E, there's clearly no whole number ratio. There's no whole number ratio to toggle between the original versus the new, the list of A through E. So we have 1/2 here. Or you could say 30.4 over 69.6 times 2 equals, okay, that would actually probably be better. So that abides by the law of multiple proportions, and therefore that's why B is your final answer for that. All right, the rest of these are naming conventions, and I must say, the irony is not lost that when I created a video here about a month or so ago, I put up, these are the things you need to be really good at and understand in chemistry. Naming is one. Clearly, I had issues here in that first exam. I did clear those up. I looked at my other exam scores. Yes, they definitely went up here. I had maybe an 85, which isn't too bad for your first exam score, but I knocked them out of the park, and the rest I had 90s and above, even some over 100. So definitely need to clear this up. If you don't understand naming, you've got to get that under control before you start testing, and of course take your final exam. So what did I do here? HBr is binary, and we know that's going to have your hydro in front, followed by your stem, followed by ic, and then of course acid. All right, so hydrobromic. I picked us. Yikes, Angie. No, we're looking at C as your final answer. Hydrobromic acid. Okay, HBr. Binary has hydro, ends in ic, not us. This one is fun, so I get to decipher my notes here. Chromium 3 oxide. So we do know chromium has a +3 charge, oxygen has 2-. And I follow what I did here below. I use chromium 2, right? But that's not what they're looking for. This would be chromium 3 below, but look what I did here. I assigned a 3-. I don't know why I did that. I could have been getting really crispy towards the end of my exam. This was question 41. But anyway, you just simply crisscross your subscripts in ionic just to balance them out. And so you'd have Cr2O3, and that matches, of course, the correct answer there. I picked CrO3. That's just a mess, and I cannot explain what I did there. I clearly did not understand putting together ionic formulas. I did not have a firm grasp on those. Now, if we go over to Na2O, look what I did here. I went ahead and added di and mono. That does not apply. That does not apply to your ionic substances. You should only apply those to covalent. So sodium and oxygen, that's definitely ionic. And so you just only need to name the metal ion first, your metal cation. So we would say sodium. And then our oxygen atom turns into oxide. So that's why we would select our option either sodium oxide, no sodium 1, no disodium, no, just sodium oxide. All right, it's for our ionic compounds. Number 3, I noticed, I thought I had it wrong, but the teacher, I remember she did a check mark there for when you got it right. X for wrong, check mark for right. So lithium nitrite is indeed Li+1 and NO2 -1 to give LiNO2. And I should have gotten credit. Looks like I got credit for something there. So anyway, I hope you found this review helpful. This video is going to go into, I'll probably set up like exam whoopsies or something like that to show you all problems that have been missed and things that need to be corrected, how I corrected them. I'm pretty confident I went and talked to the teacher after this exam when we got the scores back and went through them in class and made sure I understand, because going forward I had pretty awesome grades. So, and her exams were very, very hard. I remember Professor Walker, almost 20 years later, I remember this lady, her exams put the hurt on us. We would have 50+ questions. They were thrown in the exam center, and we didn't have a time limit, but I want to say I spent a good 3 to 4 hours on those exams and feeling pretty exhausted when I left the exam center, when I left school. So have a great day.